Hey guys, so this is Jacob Stinson again as I work through Exam P sample problems. This video will be over problem 161 from the SOA. Okay, so let's get started. So problem 161 is a deductible problem and it reads as follows. An auto insurance policy has a deductible of 1 and a maximum claim payout of 5. Auto loss amounts follow an exponential distribution with mean 2. Calculate the expected claim payment made for an auto loss. So if you need to pause the video and write this problem down, go ahead. Okay, so I'll move to my notebook. So we're doing problem 161. So the first thing I like to do when I do insurance deductible problems is I like to specify what my X of P, or where X of P is the insurance policy payout, so insurance payout. And then X of L is the loss amount. This is the total loss amount, okay? So the problem tells us that the loss amount is exponential. So just writing down all the stuff we're given, where theta is 2. Okay, so I kind of want to draw out what X of P is. We're told that there's a deductible of 1, and the claim payment caps at 5 for the insurance company. So let's draw that out on a graph here. So see if I can't get a different color here. So yeah, so let's try red. Okay, so from 0 to 1, the insurance payment's paying nothing. So from 0 to 1, there's nothing here. Okay, and then our next interval is, so we know that we'll have an X minus 1 because of the deductible from 1 to, and then here I'll show you for that interval. So we also, well, let's go and write where our cap is. So we capped at 5, okay? So we know that 5 is the highest we'll go. Well, we've already went 1, so we know this will be 6, right? So this is going to go 5 forever. Once you get the payment of 5, insurance company's not paying out anymore. So the key to this problem is, what about in the middle? Well, we know from our deductible formula that once you get past the deductible, it's X minus the deductible. So since our deductible is 1, we will have an X minus 1 in this interval. In this interval we haven't accounted for yet. So it's going to be from 1 to 6. We're going to have the line y equals X minus 1. Okay, so let's just draw this. So it's just going to be a regular linear line here. So now that we have the graph drawn, let's put it into like a regular function notation for this piecewise function. So the density function for the insurance payout is this. So oh, that's really bad. Let's redraw that. So we know it's 0 if X is less than 1. We know it's 5 if X is greater than 6, right? So when X is greater than 6, Y is 5. And then we know it's X minus 1 if you're in the interval from 1 to 6. Okay, so now we've got a lot of information. The last thing I want to show you is the general formula for when we find the expectation of the insurance payout. So this is our goal from the problem. We want to find the expectation of X of P. Well, in general, that's going to be the integral from negative infinity to infinity of your X of P times the density of the loss function. Okay? So I'm going to write the density of the loss function here. So we know that the loss function is exponential. So the density of an exponential, you can look from a formula sheet. In this case, it's 1 over 2e to the negative x over 2. Okay, so now we have all we need to solve, so let's just get to it. So expectation of X of P equals, so our first interval is 0 when X is from 0 to 1. So this will be 0 to 1, 0 times the density, 1 over 2 e to the negative x over 2 dx. Well, we know that we can disregard this because we're multiplying by 0, so we can just disregard this, plus 1 to 6 of x minus 1 times the density of the loss function, which is 1 over 2 e to the negative x over 2 dx, plus 6 to infinity times 5, or sorry, 6 to the infinity of 5 multiplied by the density of the loss function, which is 1 over 2 e to the negative x over 2 dx. Okay, sorry, I'm running out of room, but I might have to add a page here in a second. But yeah, so let's just take a look at this real quick. So as I said, the key to this problem is just knowing how to, draw the graph of the deductible, or in regards to the deductible. So this is just a general piecewise, and we know that for each value, for each interval, we're multiplying by the insurance's payout at that interval. So from 0 to 1, the insurance company isn't paying anything out. From 1 to 6, the insurance company is paying out X minus the deductible, which in this case is 1. And then once you get past 6, the insurance payment's going to cap at 5. Okay? So let's keep going. So this is equal to, we disregard this one. So 1 to 6 of X minus 1 times the density, 1 over 2, e to the negative x over 2 dx, plus 6 to infinity of 5 halves e to the negative x over 2 dx. So I'm running out of room, so let me add a page here, because I feel like you would have enough room to, you probably have already written everything down so far. Let's add a page. So I'm going to rewrite this integral as 1 to 6 of 1/2 x e to the negative x over 2 dx minus 1/2, the integral of 1 to 6 of 1/2 e to the negative x over 2 dx, plus 6 to infinity of 5 halves e to the negative x over 2 dx. So I'm going to pull all my constants out. So this is going to be 1/2 1 to 6 integral of x e to the negative x over 2 dx minus 1/2 integral 1 to 6 of e to the negative x over 2 dx plus 5 halves 6 to infinity of e to the negative x over 2 dx. Okay. These two integrals right here, these two are fairly easy to solve. I will solve this one here by tabular integration. So I'm going to come over to the left side and do it over here. So we know about tabular integration that this is kind of used for like when you're integrating exponential, where it repeats over and over again. So our u will be x and our dv will be e to the negative x over 2. This is just a different way to do integration by parts. So you take the derivative until x goes to 0. So derivative of x is 1, and then derivative of 1 is 0. So we're done. We know that this term is plus, this is minus, this is plus. So we got to alternate signs. Integral of this is negative 2e to the negative x over 2. Integral of this is 4e to the negative x over 2. And then these go together and these go together. And this is the process. So let's keep integrating. So this is 1/2 times negative 2x e to the negative x over 2 minus 4e to the negative x over 2. Let me erase this line. Okay. And this goes from x equals 1 to x equals 6 minus 1/2. We know that this integral is negative 2e to the negative x over 2. This goes from x equals 1 to x equals 6 plus 5 halves times negative 2e to the negative x over 2. So I'm just going to, at this point, I feel like if you're studying for the exam P, you're pretty comfortable with integrating. So this final answer ends up being 2e to the negative 1/2 minus 2e to the negative 3. And I think that's letter C. Yes, letter C. All righty. Well, yeah, so this is, as I said, this is SOA number 161. Please do subscribe and like and comment. Please give me any pointers and updates that would make my explanations more clear. We know that, anyone that's studying for Exam P, we know this is a very tough exam, so I really hope that there's at least some people out there that will benefit from these videos. So that's all for right now. If you have any specific requests for videos, like problem numbers, just please put those in the comments. And y'all have a great rest of your day, and thank you for watching.